Have you ever wondered how machines learn to cluster similar data inputs? Well, the answer lies in competitive learning. A subset of machine learning, competitive learning falls under unsupervised learning algorithms. It involves a network of artificial neurons that compete to become active in response to a specific input. The neuron with the highest score, often the one that best matches the given input, is updated, while the others remain unchanged. This powerful learning method helps us to automatically cluster similar data inputs and discover patterns in data where no prior knowledge or labels are given. Let's dive into an explanation of competitive learning. Artificial neural networks frequently use competitive learning models to classify input without labeled data. The process commences with an input vector, which could be a dataset that's presented to a network of artificial neurons. Each neuron has its own set of weights, which operate like filters. Each neuron then calculates a score based on its weight and the input vector, typically through a dot product operation. The neuron with the highest score, referred to as the winner, is updated by shifting its weights closer to the input vector. This winner-takes-all strategy leads to the formation of clusters of similar data over time as neurons become specialized towards input vectors they best match. For instance, consider an e-commerce business wanting to segment its customer base for targeted marketing without prior labels or segmentation. By feeding customer data into a competitive learning model, distinct clusters like high spenders, frequent buyers, or discount lovers could be automatically identified, facilitating tailored marketing strategies. Let's delve into a step-by-step example. Assume a dataset composed of one-dimensional input vectors ranging from 1 to 10 and a competitive learning network with 2 neurons. First, the weights of the 2 neurons are initialized to random values. For instance, neuron 1 has a weight of 2 and neuron 2 has a weight of 8. Then an input vector is presented to the network. Let's say our input vector is 5. Next, the distance between the input vector and the weights of the 2 neurons is calculated. The neuron with the weight closest to the input vector wins. This could be calculated using any distance metric, for example, the absolute difference. So we have neuron 1 with a distance of 3 and neuron 2 also with a distance of 3. Since both distances are equal, we can choose the winner randomly. Let's say neuron 1 is the winner. The winning neuron's weight is then adjusted to bring it closer to the input vector. If our learning rate is 0.5, the weight update for neuron 1 would be 3.5, while neuron 2 remains unchanged at 8. Finally, the process is repeated with all the other input vectors in the dataset, updating the weights after each iteration. So, there you have it. Competitive learning in a nutshell. A powerful tool that helps machines discover patterns and groupings in data, enabling us to make sense of the world around us.